Okay, in this video, we take a look at the texture nodes and Cinema 4D shaders that Arnold supports. So open up this shader network that is assigned to our geometries, and let's take a look at these texture nodes. There are three noise nodes that Arnold supports: this cell noise, this simple noise, and the native Cinema 4D noise shader. Let's add the cell noise, the noise, and the C4D noise to the work area. And start with the simple noise and set it as the beauty shader and run the IPR. And this has only a traditional noise with some basic controls. Let's increase its scale to 10. And in the main tab, you can increase the octave for more details, distort the noise, increase the contrast by increasing the amplitude, and so on. Cell noise is another Arnold noise that has about 7 patterns. Let's set it as the beauty shader and increase its scale to maybe something like 20. In the main tab, we can access different patterns that this noise has, including noise 1 and 2, cell 1 and 2, whirly 1 and 2, and alligator. And we also have Cinema 4D Noise Shader, which gives you tons of noise patterns and controls, and Arnold supports it out of the box. So that's about the three noise nodes that Arnold supports. Next, we have this checkerboard pattern. Let's add it to the work area and set it as the beauty shader. You can increase the frequency to get a smaller pattern or change the colors and so on. We talk about crypto matte shader in the rendering section, but simply put, this is the best way to generate automatic geometry mattes for post-production. We talk about it extensively later on. Next, we have this flakes shader. Let's add one to the work area and set it as the beauty shader. And this one creates a procedural flake normal map that can be used for materials such as car paint. Before having the car paint shader, we were using this shader to generate flakes, but you can still use it for more creative purposes as a normal input or specular roughness or anything else really. Then we have the image node that we use to load images. Let's add one to the work area and load this woodparquet.png image. For now, we can stop the IPR and open up a material preview and use the Arnold plane preview. Technically, image node is a color shader which performs texture mapping using a specified image file. Under the coordinate tab, you can control the position, size, and rotation of this image on the surface. You can control how the texture is styled within the frame using the scale UV, flip, wrap, and swap attributes. Under the image attributes tab, you can define the color space of the texture depending on the color management that you are using. In this case, we are using ACES, and this is a color map. So the color space will be utility sRGB texture. Filter is the interpolation method used to filter the texture. Smart by Cubic works fine in most cases. MIP mapping and texture settings will be discussed in the rendering section. MIP mapping bias here offsets the computed MIP map level from which the image is sampled. A negative value will force a larger MIP map level, which results in a cleaner image, and a positive value will force a smaller MIP map level that will result in a blurrier image. We talk about this stuff later on in the rendering section. You can multiply or add a value to the texture. You can enable single channel and output just RG or B channels of the texture. And if you have a sequence of images, you can go to the animation tab and enable animation to load the entire sequence. We talked about layer and mix RGBA and noise. And finally, we have this ramp float and ramp RGB. Let's add a ramp RGB node first and set it as the beauty shader. Ramp RGB is a gradient ramp basically, which you can use it independently as a gradient, or you can connect a texture to its input and remap the values of that texture. Let's add an image node and load this BW28 texture and connect it to the input of the ramp RGB node. And now we can use this gradient to adjust the input texture. Maybe let's change the black color to a mid-gray and the white colors to black. Or I can make the right dot closer to the left dot or vice versa. So it provides a lot of control to adjust your texture values. For these kind of adjustments, I tend to use the ramp float node as it provides more control, but ramp RGB is more visual and maybe easier for some people. I'm gonna disconnect the image and reset the ramp to its default value. We can change the ramp type to U, V, diagonal, radial, circular, and so on, and change the colors of the ramps as well. We also have the ramp float node, which is one of my most used nodes, and we can connect the texture to its input and change its values using this curve. We have been using this node a lot throughout this course, so you should be quite familiar with. Now let's come down to the C4D shaders. We have the Cinema 4D bitmap. If you don't like the Arnold image node, you can use the Cinema 4D bitmap to load your images. We talked about C4D noise, and substance shader was covered in its own lesson. And this vertex map node allows you to load vertex maps and use that data in your network. Let's grab this abstract object and select some polygons from it. Now from the select menu, choose vertex weight and set the value to 100% and mode to set and press OK. Now drag the vertex tag to the vertex map field in the vertex map shader and set the shader as the beauty and run the IPR. And now we can use this data however we want for a mask or specular weight or anything really. Let's quickly add 2 Lambert shaders, one pink and one orange. Now add a layer shader. Set the pink one as the first layer input and the second one as the second layer input. And set the layer shader as the beauty shader. And now we can set the vertex map as the layer 2 mix input to work as a mask. Cool, so in this lesson we learned about texture nodes and Cinema 4D shaders. See you in the next video.